everyone. So I work at SK South Africa in Cape Town, and we actually have quite a lot of opportunities in our positions to teach. So I'm going to speak a little bit about the various contexts that we teach in, and then describe some of the ways we teach in those contexts. First using IPython, just vanilla IPython, and then using the notebook. I'll spend more time on the notebook, and then at the end do a bit of a slightly risky web-based live demo of some really cool stuff. Cool. So the first two contexts that we've been teaching in are Kenya and Namibia in Nairobi and Windhoek. And the reason that we work there is that our project is actually a Pan-African project. Although most of the South African SK telescopes are going to be in South Africa, we're actually going to have a few in other African countries. So in the lead up to that, we've been working with them, with some university students, and doing some radio astronomy and astronomy tutorials there. So I'll speak about that first, and then I'll get to speaking about some of the teaching that we do closer to home, more routinely in Cape Town. So Kenya and Namibia, we run these things called ZA workshops, which stands for Joint Exchange and Development Initiative, which is a style of workshop pioneered by some guys at AIMS in the African Institute of Mathematical Sciences in Cape Town. The most recent one is actually a machine learning one. You can see the link there at the bottom if you're interested. But it's just a style of workshop that's meant to be very flexible and very reactive to participants' needs. So you can change things kind of on the fly if you realize maybe your students have different backgrounds to what you expect. Or if you're working with a bunch of academics, they have different skill sets than what you expect or whatever. So in both of these cases, we had groups of about 12 to 15 students and 30 and above. Windhoek, they were slightly younger. Namibia, the picture over there is Hess, and Namibia, the students, they were slightly more advanced students. And in these contexts, we use just IPython. It's just IPython vanilla. So we developed a tutorial that was Python from the ground up, assuming a little bit of computer science background, but no Python. And the eventual aim was to get them towards astronomy, radio astronomy related tools. They were given a physical handout to follow, so they actually had to do the Python themselves in the terminal and work in little groups. And the tutorial was specifically designed to force them to use the IPython help a lot, so they get familiar with that, and to actually have errors embedded in the tutorial so that they'll also get used to debugging their own code. So here's an example of a page from it. This is a section where we were showing them how to use some math-calculative tools, and the assignment in this section was to reproduce a figure from an academic paper. So the plot there is just the figure that they had to reproduce. So overall, this actually worked remarkably well, especially in Kenya. The use of the IPython help was really very empowering for them. One of my favorite moments in Kenya was when we kind of let them work and then circulate around the room and kind of see how things are going. And I went to one group of students who were obviously stuck, and I offered them some help. And they said, no, we're reading the help, we'll figure it out. And that never happened. Students never do that. So that was actually amazing. I don't know if the Kenyan students were amazing or that our tutorial was amazing. I don't know. But yeah, that was pretty cool. And the other real win of using IPython rather than teaching them to write their own scripts and giving them scripts to edit, which is what is often traditionally the way these things are done, is that because it's interactive, and it's interactive Python, you get this quick feedback loop where students get something wrong or don't understand something or get an error message, then have to figure out how to fix that, and then fix it, and then get back to the rest of the tutorial, carry on, find an error, fix it, and going through that loop very quickly and easily, repeatedly, is incredibly empowering. It teaches them to actually fix their own code, which is unusual for students. So that worked very well. And it's also much easier for tutors. So there were only actually 2 tutors for a class of 12 to 15 students. So you don't want to be spending your time hacking away through reading someone's awful, first time Python programming script. In IPython it's much easier. You just have to go through a few lines and quite quickly see what the variables are. That was a big win. And the next one, which is my favorite one, was sort of discovery through experimentation. And it's really because of all of this, students will much more willing to try things. So try different functions or fiddle with parameters and actually themselves teach themselves, which is really how everyone learns ultimately, from teaching yourself, not just by listening to someone tell you what to do. So that was a big win of using this method. The two main challenges, which are going to come up again and again, are number one, Linux proficiency. Most of them had never used Linux before. So working in the terminal posed some challenges and setting things up posed some challenges. And I've written here standardization / versioning, which I've used as a sort of umbrella term for the problems you get when people are using their own systems and they're all different and you spend a million years trying to get the right version of things with all these people's computers. In Namibia, we use virtual machines, but even that was problematic because lots of them had old laptops and things would just grind to a halt. So there were just a whole lot of problems related to actually everyone using their own systems. Right, so South Africa. So that was working in African partner countries. Now I'm moving closer to home. There's sort of two styles of teaching that we do out of our office. The first is called SK Classical Tutorial. So this is when often a university will come to us and say, we want you to run an afternoon-long tutorial on radio astronomy for our students, or maybe we'll have interns. In this picture over here, this is something called the Youth Development Program, where something like 20 students came to our office for a few days to learn about what we do, and we need to present them with some material. And we use the IPython notebook for this. We put it all together in a suite of tutorials which you can get to at the bottom if you're interested, and I'll do some demonstrations on them later. The second main teaching content we have is a course that we run at the University of Cape Town in radio astronomy for honours level students. It's called NASP, which is National Astronomy, National Astrophysics and Space Science. That's a picture of the current NASP class sitting on the top of the Harshad radio telescope. And in this content, it's sort of more traditional lecturing and tutoring, so actually standing in front of the class and exams and the whole university jazz. Okay, so to explain how we've used the notebook in these various different contexts, I made a little graph, sort of my attempt at an SKCD style classification graph. So what this is a graph of the emphasis of your notebook. So the x-axis is the emphasis on Python, using Python and Python skills. The y-axis is the emphasis on some kind of discipline-specific content, so machine learning or radio astronomy or bioinformatics or whatever. So right at the bottom is just a straight Python tutorial, so that's what it would be if we took our IPython notebooks that we use, our IPython vanilla that we use in Kenya, just translated into a notebook. One up from that is something that I call the content/Python lab. That's the classification that I used for the way I used the notebook to teach the Fourier transforms section of the recent NASP course. And in that case, the overall content that I wanted to get to the students were the Fourier transforms, theory and applications and whatnot. But I also needed them to learn how to use the notebook, and I needed them to learn how to use Python a little bit because they were very unfamiliar with Python at that stage. And I wanted them to become comfortable using the Python Fourier transform packages so that they could go on and do that themselves. So there was content, but there was also quite a lot of emphasis in using Python, which meant that my Python code was exposed to them, and there wasn't any hiding of things. I actually wanted them to use the code and learn how it was used. Moving right up is something that I've called a content tutorial, which is what we use in our short 2-hour-long tutorials, where the main emphasis is exposing people to radio astronomy ideas and our data from the Cap-30 telescope. So there's a little bit of exposure and introduction to NumPy, but beyond that, it's mostly the data. Moving one up is what we call interactive lecture notes. And this is a new thing that we just started in the NASP course, which is actually really quite interesting, where you actually put together all of your lecture note content inside the notebook, which you can do because of the Markdown and LaTeX capability. It probably seems kind of like overkill, why would you do that? But what is really cool about doing it that way is that it means that all the work examples and the plots in your course content can then be interactive. So students can go along to some other mathematical work example and plot intermediate steps if they want, change variables if they want, actually score things in the lecture notes, which is really cool. Obviously you can't do that in a PDF, obviously not. And finally, the top one is something that we haven't used but I've seen used. I've called it a package content tutorial. So say, for example, you want to teach a bioinformatics course, but you don't want your participants to worry about any Python. So you make a package around that makes things as simple as possible to run things in the notebook, so they're not having to worry about almost anything. It's just a few simple functions that they can add things to. And I've seen people do that online for courses in sort of advanced numerical systems, that kind of thing. Okay, so the simplest case for us running a notebook would be a computer lab, say at UCT, where all the computers are the same. Everyone has their IPython notebook in their home directory. They can run it and work through it, maybe with us talking them through it a little bit. Even in this completely simple case, there's two challenges. The first is Linux proficiency again. Lots of students haven't used Linux much before, or if they have, they've been using Ubuntu and they've only ever clicked, they haven't actually used the terminal. The second thing is this issue of standardization / version again. Even in a computer lab where everything is the same, we found that we were developing the notebooks in more recent versions, and we were using magics and widgets that weren't backward compatible with the horrible notebook 2 in the lab, and then we had to beg the system administrator to change things, and it was all slow, and blah, blah, blah. So even in that simple case, there's issues with that. But in the more complex case, when our students are bringing their laptops and wanting to do assignments on their laptops and so on, those same kind of problems emerge of having to install things and all the hassle with that, and it taps into your class time, sort of fighting with those kind of things. So what I'm going to do is talk through some of the tools that we use and can potentially be used to get around those problems. So the first is GitHub. Okay, it's not a Python tool, but it plays really nicely with some of the other tools. And our tutorials are now all on GitHub. The second is something called NVIDIA, which is a free web service that gives you static versions of notebooks. The third is cloud computing in a couple of different contexts, which I'll go into more in a moment. The last two are Run IPy and NVConvert. You already saw NVConvert in Toby's talk. Run IPy just runs through a notebook in the terminal without having to open in a browser. NVConvert can convert your notebook into various formats. The way I use these two is that students would submit assignments as IPython notebooks, and then rather than having to open each one in a browser and type through everything, I would just run it from the terminal, convert it to PDF. I know this is bad, but I would then print it out and mark it on the printout and hand it back to them. I know that's bad, but I don't know how you mark. I'm sure you can figure out a way to mark on a notebook, but I haven't yet. So that's how I use those two. Okay, so some of the ways that we use some of these tools. Have your IPython notebook in GitHub, and then all of that works very well with NVIDIA. I'll give you an example now. In fact, let me give you the example. So here are our tutorials. So our tutorials are all in sksa/tutorials. So here is NVIDIA, sksa tutorials, edit, these work, internet. Yes. And there we go, and we can browse through static versions of our tutorials very easily. I'll go through the tutorials themselves. We'll talk through in a moment. But you can browse through them and see static versions of them like this. And this can be useful for a couple of reasons. Let's look at radiometers. So this is an example of lecture notes that are actually written in the notebook. With some interactive plotting that then you can go change things. This is useful because you can lecture from something like this for one, and for two, you can run it without actually having an IPython notebook running on the computer. So if project in the lab that you're using a Windows machine, and you need to show someone something in a notebook, you don't actually have to have IPython running. Okay, next set of cool tools. Okay, so now we're moving to the cloud. When we run tutorials where a whole lot of students come to our office, they'll bring their laptops, we'll sit them in a room, and we'll run an IPython server on one of our machines. And they'll all just log into that and run the notebook themselves. The first time we did this, we didn't realize that obviously we actually need to have copies of all the notebooks for the students, so that was a bit of a hack. But we subsequently got a bit smarter, and now we make a separate folder for each student and check out our tutorials in each folder. So that already works actually amazingly well, because it means 15 students from the University of Western Cape can all bring their own laptops, can be running whatever on that laptop, but they can all do the tutorials. It's actually almost ridiculously easier than any other method we could have to do this. It means we don't have to have our own machines, we don't have to tell them to set up things, install things beforehand. It's already pretty awesome. Next level of awesomeness is you can set up the same thing on an Amazon Web Service with EC2 instance, which we've done, and then we can use that in sort of a more portable way, so wherever you go, you can run that. And we did that by setting up a little fabric automatic deployment, so everything that's needed as dependencies for our tutorials we can automatically put on a Amazon Web Service instance, and then we have something quite easy to use for people. Here's an example of a running Amazon Web Service instance. So this is how we would do it. So our students would just literally navigate to that, from cutting and pasting from an email or something. And we'd open the folder. I'm Laura Ruchter, so I open my folder, and here are all the tutorials that I can do. This is the single dish. Quite a nice one to show people. It is a little bit slow. This is the one that provides a bit of an introduction to NumPy, and then gets further down to actually working with some of our H5 data from one of our early single antennas, and then in the next tutorial in this section, some of our Cat7 data. So this is already pretty awesome. It means you don't have to worry about a lot of stuff you have to worry about before. And also you don't have to worry in this context about students' Linux proficiency at all, because all they have to do is shift enter through a notebook. They don't have to actually do anything Linux related. And the next level of amazing is something that I only discovered a few weeks ago. So the star is because I haven't actually tested this to students, so maybe it won't work, but I have great hope for it because I think it's amazing. So Sage Math Cloud, it's Wakari, the service provider, is a similar thing. I just find Sage Math Cloud less laggy and much more user friendly, so I recommend it. And I'll show you an example of it now. But this takes away pretty much every problem we have had, so it's amazing. So let me show you. Now, and can you imagine, the context to imagine is, say you have a class of 100 Math 1 students, you want to give them an assignment in the IPython notebook. You do not want to have to hack around with 100, making 100 folders and some server that has enough, power for that, blah, blah, blah. So you just tell them all to create their own Sage Math account. So let us create a Sage Math account. So here is our temporary Sage Math account email address. Yes. I tested this, but the Sage Math has about 15 Gorilla Mail accounts at the moment. So here is PyCon ZA, my email address. Okay, there's our count. That took 1 second. We go to projects. We create a new project. So Sage Math Cloud, it's a cloud service that was specifically designed for Sage Math, which was meant to be an open source alternative to MATLAB. But it's also recently been set up to be very user-friendly for notebooks, IPython notebooks, and to have all the packages that you would need pretty much to install. So it already has NumPy and SciPy and Max.load and H5Py and a myriad of other things. And the guys who run this project are also incredibly responsive if you want them to install other things. Okay, so let us, so here are our students. We tell them that we want them to use this set of tutorials on their Sage Math Cloud project. Click new, cut and paste, enter, and this will take a few seconds just to upload. But look at that, you didn't even have to open a terminal. That was amazing. All you had to do is cut and paste. And here we go. There we go, it's magic. It was ridiculous. So let's do our single dose data analysis again. It does take a few seconds here to actually put the notebooks up. While we're doing that, I'll also say you can also pip install things if you need extra things. If you have your own code that you need to use in this. You can't actually pip install directly at the moment because of security problems. They don't allow that for the moment, but you can clone projects and then pip install them to user. It takes a little while to open, but once it's open, it's actually runs pretty fast. There we go, and there we have it. So cool, really. I mean, that in 2 seconds I pulled that up. A student could do this in the first 5 seconds of a lecture, rather than the experience we had where the first half an hour of the first lecture is showing them how to do things and showing them how to use the terminal, blah blah blah. This is wonderful, and it can be used in a very simple way by students who don't have a lot of experience. But there's also features that can allow you to use it in a much more sophisticated way. So you can, if you want, pull a terminal app. And it's you can work on the terminal if you want. This is where, if you wanted to install stuff, you could clone stuff out here and work here. There's also LaTeX, that you can work on LaTeX documents, and you can also work on collaborative projects with this. So if you wanted to, you could have 3 people all working on the same project and working on the same notebook, which is cool. I haven't needed that feature yet, but I think it could potentially be quite awesome. So actually, maybe I should show you actually. So say we want to add PyFM. So PyFM is it's for astronomy, very accurate astronomy related software tools. So the math card doesn't currently have PyFM in it, so let's get clone it from the terminal. We could have done this from the cut and paste block again. So there we have it. Oh, that was a really messy way to do that. Oh well. And then we're going to see if that works. Okay, it should work. Oh, it's working. So there you go. It's as easy as that if you want to do something more sophisticated. Yeah, I won't say any more about that. I'll go back to here. Okay, so that is pretty amazing, living the dream. Okay, so in evaluation of our use of the notebook, the 2 challenges, I think the main one, especially when we were first using it, is not budgeting enough in introductory and setup time, sort of thinking it would be obvious to the students, once you've said shift enter to them once, and once you've explained some of the shortcuts once, but actually it took them a bit more time, so we should have spent more time on that, especially on the context where they're working on their own laptops and that sort of thing. And I put standardization version again because it was a problem in our original attempt for the notebook, but with these newer tools, we're actually almost past that. We can almost completely avoid those problems. The wins, there are so many of them, pretty much all of the IPython wins, and then the fact that it's browser-based, anyone can use it, cross-platform, everything in one context, which is very good for teaching. You don't have, you put in one place your code in a text editor, it's all there. Less necessity for Linux expertise, almost no necessity for Linux expertise in some contexts. It's very convenient for assignments. I think the students that I work with at least are not quite happy doing and submitting assignments in a notebook, which is also easier to mark than a script because everything is there, the output is there, all in one thing. And Markdown and LaTeX means that we can actually write notes and whole lecture, coursework in the notebook in an interactive way, which is really cool. And this issue that I spoke about for the IPython vanilla of sort of discovery through experimentation, teaching like this really lends itself to that. I know for the Fourier transform section, after a while, students were quite happy fiddling with different functions, combining them in different ways, and realizing that changing things didn't break things. It was just a way for them to explore. That was actually incredibly empowering for them, which makes this a really good tool. So here are some of the course evaluation notes from the students, obviously only the nice ones. And yeah. I resisted the urge to correct their grammar or spelling. So I thought that was quite good. There was obviously a good response, and I think they really enjoyed doing it. And I think as we get more used to teaching with it, and as we get more used to using the newer tools, it's actually just going to become a better and better experience for them. And finally, this was just an idea I had that I thought I might as well share before I end. About a year ago when I first started doing the Python tutorials that we run, sort of just afternoon-based ones with a few students coming in with their own laptops, it occurred to me that the IPython notebook would be a really cool way to supplement high school syllabus work, like in science, in obviously computer science, and math. So I thought, oh, well, let me try that. Let me try and make some notebooks. And I spoke to a friend at the school and kind of got that organized. And then after getting it organized, I realized I would have to do it on a small computer lab, which would run Windows, and I'd have to install stuff. And I just couldn't bring myself to do it, so I gave up. But then I've just discovered all these amazing new tools, like SageMath, which I think could work so incredibly well in this context. So I think that would be something really worth doing. If anyone would like to, maybe if someone's already doing that, or if anyone would be interested in putting together a bit of a suite of high school support notebooks, and then maybe trying them out in a couple of tools, I would really like to do that. So if you want to, then please do try and do something like that. So, yeah, thank you.